doo. Dooby 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 doo. Dooby 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 doo. Dooby dooby doo. Yeah, this looks okay. We have sound, we have vision, we have me. Hi. Welcome, welcome, welcome. Yeah, what are we doing today? Refactor and improve. Well, what does that mean? Well, what do I mean by refactor? Simplify, make sense of what we've done. Yes, that's a good explanation of what I mean. What other people mean by refactor is just move stuff around. Yeah, I'm not sure we'll be moving stuff around. I think I need to make sense of what we've done. We've got a working prototype. So that's what I mean by refactor. And improve, its functionality isn't quite right. So let me show you. I started placing in to-dos. To do, we want to poll all events for this frame. We're currently running a loop, and because there's no rendering system, there's nothing happening in this loop, it's acting as though we're polling all the events, but we're not. We're only polling one event. And then we're polling another event. That's not the way it's intended. We should be polling all events for each frame. Empty the event queue that the operating system has given us. That's going to be a biggie. That's where we want to end up. But in the meantime, we've got this refactoring. So, I was going through the code yesterday and obviously adding to-dos. Oh yeah, to-dos. Let's have a look at that. Well, there's 12 there, so we might be adding more as we go through. But that's okay, that's a start. There's a few to look at. This setup, does this make sense? No. So how are we running our program? We're going to window create. Here. What's wrong with this file? It's alright, I've got a cup of coffee, I've got a minute. You can decide for yourself what's wrong with this file. It's an interface. It's an interface between the user, the main program in this case, and the API, the Windows 32 API. What does it actually do? And that's what's wrong with it. What does it actually do? Simple answer, nothing. This file does nothing. It's got no functionality. Everything is a straight pass-through. All we're doing is we're creating this structure, which isn't needed, because we've already got the Windows 32 structure. It's not doing anything useful, is it? Okay. Simple answer. This system folder. Move to recycle bin. Bye. How was that for a refactor? Oh, we say. That's a mess now, isn't it? We've got problems all over the place. Oh, look at that. Interesting. All right. Well, we've got a couple of errors come up. Okay. Got rid of those errors. That creates another error because now we've got this window thing here. So it isn't window anymore, is it? Oh. What is it? We've got the Windows 32 API. Alright, let's have a look at that. It's create. It's here. Under Windows 32. Does that work? It does, but now we haven't got these. But we've got our create going. We just don't have our polyvent and window is open. Okay. So we've got create, pol. Okay. Does that look alright? Yeah, that looks alright. And we've got a Windows 32 structure now. So our app is now Windows 32 structure. We've got a window is open. Okay. Does that work? No. Oh. Window is open, yeah. Oh, we've got the same program. Alright. That's interesting. And we've just dropped a load of files. Why is me... Ah, good, my mouse isn't working. Good. And it works. Huh. Hold on a minute. That proves we didn't need it. And it's also more clear to the user here exactly what type of window they're creating. Because later on, that might be a Linux window. Ah. Are we going to do a Linux version of this? Ah. That opens up options. But there you go, that was a simple refactor. It shows you how you can refactor. You don't change your test usually, you change the functionality within your files to suit the test rather than the other way around. Don't try and suit your test to your files. Oh, that coffee's lovely. Alrighty, I think we're okay with that. Next problem. This is part of the refactoring that I call readability. If you look through here, everything starts with Win32. That means it's all part of the API. But this isn't. This isn't part of the API. This is using the API. Oh, you might have noticed I've put a load of notes in. Don't worry about the notes yet. We'll get to them. So this is actually using the API. It's not part of the API. That's the API. That's the API. That's the API. This isn't. So it really shouldn't be prefixed with Win32, should it? Okay. Simple answer. Extension Rust Analyzer wants to make refactoring changes with this file move. Okay. Do what you want. Okay. We'll come back to you. So what it's done is it's taken that, it's done that, it's done that. That's still okay, that's still okay. We haven't broken anything here. Am I happy with that? I think I am. Application shuts down properly. Ah. Okay, so we now know that that isn't part of the Win32 API. Well, neither is this either. This is using the Windows 32 API. So this is all functionality as well. Ah. Got a feeling we should do the same here. Okay, feel free. It's telling me we're breaking, are we? Events window procedure, okay. Alright. Now we have events and window. That's looking better. Everything's okay here. Everything's okay here. It's refactored for me. Everything's changed. Things look okay. Does it look okay? Yeah. Application shuts down. We've got the same program, but it's slightly different. We've now got create, poll event, window is open. Okay. Yeah. I think I'm starting to prefer that. It's running okay. Right. Fine. So we've managed to rename, and things now start looking more semi-normal. We've now got a module for Windows 32 API, and we can access the Windows 32 window. I don't think we can really access too much more of it. Don't think we can. No, that's the only public that we've allowed. So events is hidden, all of this lot is hidden. Okay. Excellent. So we've got minimal usage, a minimal entry point called Windows 32. We can create a window, we can poll events, and we can check whether the window is open. Right. Now we're getting somewhere. And we've got less files to deal with. Everything's started to simplify down. Alright, I think I'm going to take that. I'm going to take that as a success. So as you can see, we've scrapped things and created things. So we've got deletions. Oh, we've got an awful big mess. So refactor. Names and and delete useless files, because that's what they were. That's okay, that'll do. Refactor names and delete useless files. That's what we've done. Am I happy with that? Yeah. I'll do for now. Okay. Right, we've got a start. We've got a start to our day where we've cleaned up the code name-wise. We need to now start looking at the to-dos. Yes, we get to the to-dos. The main to-do really is this one here. Yeah. So we need to poll all events for this frame, and we're not doing that. So in SFML from a couple of weeks back, that's the line that we used. I just pulled it out of that file, copied it over and stuck it into a note. That's the kind of instruction that we gave when we were checking for input on the window whilst making our very, very simplified game using SFML, Simple Fast Media Library, a crate. And I've been using SFML as a guide to how I want this to look to the user. I want to be able to put a while loop in here. Simple answer, do it. There you go. Expected a bool, found nothing. Alright. You expected a bool, did you? So we need to return a bool on poll event. Okay. I love the way this language works. So let's go to poll event. And return a bool. Take that off. Expected a bool, found a nothing. Oh. Oh yeah. Well, that's an event, isn't it? Alright. That's here. So self events poll. Events poll. Oh, we want a bool here. Well, we better return one, hadn't we? How about true? That's always a good one, because if we've done a message, we're going to return true. Okay, everything's happy now. But where's the problem? It's always going to return true. We've got an endless while loop. How do we get a false? In fact, how do we get a false? Let's look at that a bit more carefully, shall we? So this is our code. Peak message. It returns a bool. Okay. How does this work? Unused variable. Yeah, I know it is. Expected a semicolon there. And it's also giving back nothing. Okay. Let's just reform this one. There we go. I32. That's better. What have I got here? It's doing something weird. Okay, let's get rid of that one. Right, okay, so this is our new command. We're getting an I32, so that bool that's coming back isn't exactly a bool. It's an interpretation of a bool by the Windows API that is actually an I32. Okay, so I've added the safe block, and it moves the semicolon outside. Huh, that's interesting. So this message, I don't think I've got enough screen now, have I? No, I haven't. Oh, that's a shame. I will move it back down here. so that I do have enough screen. What is this thing doing? Right. So we've now got this I32. So if it comes back with a 0, it's false. Oh. Sounds good to me. So if new message is equal to 0, return false. Yeah. And that's all we should need. Theoretically. So we've got a true, we've got a false. Oh God, thank you. We've got a true, we've got a false. So if there aren't any messages, we just break out of everything. Okay. Sounds good. And it works. Huh. Well, that was easy. I like that one. Yeah, we've done that now. So we no longer need her to do that. So we've actually got this working properly. So our events are working properly. Our main now does what it's supposed to do with a while loop. So that's done. Well, not quite done, but it's done for now. We are now polling all OS events for this frame. So we're now doing what we should be doing. The fact that we're not doing anything afterwards is immaterial. Okay. Still haven't decided on how we want to exit the loop, so I'm going to leave that alone for a second. And have a look at the next issue that I have with our prototype code. And that issue is derived from the fact we were using 20-year-old code in the Learning Center on the Microsoft MSN website to generate this code, learn how to put it all together, convert it into Rust and all that kind of stuff. Well, we were using a rather old, well, the whole manual's pretty damned old. But, yeah, there's that kind of thing to think about. Something came up whilst I was checking through the code. Now you're only telling me we've got... Ah, right, okay. This deprecated. So in our Windows 32 libs.rs, we are asking for register class W. we're asking the Windows API to use that function. Okay. Interestingly, if we go over to this function, let's just close things down. So that's control click, loads up my page. Oh, I haven't finished renaming stuff. We'll come to that. Register class W. Note, the register class function has been superseded by the register class EX function. You can still use register class, however, if you do not need to set the class small icon. Oh. Really? What's the class small icon? So we do have create window EX. We don't have an EXW. Huh. Yes, we do. You can see how I'm having problems with the manual. It redirects us through to EX. Yeah, if you look right above class W, we've got EXW. And we're using create window EXW, which is an extended wide function. Oh. So it's no longer a wind class. Oh, this is going to get confusing. There is a wind class EXW. Yeah. Do we have access to that? Not in here, we don't. Okay. So hold on a minute. Are we using the right thing here? You can see the problems, can't you? That's a structure. We're using this one. This structure has been superseded by a wind class EX structure used with the register class EX function. But we've already looked at that and it's not right. It's EXW. You can still use wind class and register class if you do not need to set the small icon. Where is this small icon? So still got style, the Windows procedure, CLS extra, Windows extra. instance icon, cursor, HBrush. It's exactly the same as what we've got. Yeah, that's correct. Okay, let's have a look at this Windows class one here. Yeah, we've got H icon small at the bottom. And style goes out the window. This is completely different, isn't it? Style. We've got CB size. Alright. The size in bytes of this structure. Set this member to size of Win class EX. Be sure to set this member before calling the get class info EX. Huh. I'm not sure I want to make this change. Not yet, anyway. Size of Win class EX. I see. That causes a problem. Will we have a size at the stage that we're using it? But we're in this file, so I'll deal with this file now. Yeah. About this file. Because we're still doing refactoring. This file, I've called it funcs. It contains one function. Everything else is a struct. Okay. It isn't funcs, is it? It's structs. Yeah, okay. Yeah, everything works there. Yeah, it's changed it over. Good. Good, 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 good. Alright. I think that's a good idea. To actually call it what it is, rather than what I thought it might be. That now makes more sense. Type structs and labs. Yeah, ellipse. Okay. We'll go back to the to-dos. Right, so we did have this. Yeah. I mean, I'm happy with register class W, really, but we do need to change it. In the future. Alright, we're down to, what, 10 to-dos? And this is why I'm looking at it. I've been looking at improving our win class, but now we know, we might need EX here. Especially our cursor. So our cursor isn't doing very well. Yeah, it doesn't change. It doesn't know what to change our cursor into. It does when it hits the borders, but in the middle of our window, it just remains, it's not updating. Our cursor is not updating. A lot of people say, well, that'll fix itself, don't worry about it, Blades, it'll be okay, it's fine. It shouldn't be like that. It shouldn't be like that. It should know to load the cursor. So the win class, if you remember right from the very beginning, is how our window behaves. We're instructing the operating system that we want our window to behave in a certain way. And there's all of this stuff here that we can add into it. I think we have to change this over though. I want to make a save point before I do that though. I've got a horrible feeling about that this is going to mess up. Rename. So it was what, funcs? This was Win32. Win32 funcs. Rename to Win32 structs. Okay. That went through successfully. I want a place where I can go back to. Definitely. Yeah. Alright. So if we start somewhere like that, we should be okay. It's going to change two things. Okay. And we're going to be looking at our structs, aren't we? Yeah. Okay. So we have to match this to this. That in itself doesn't seem to be nasty. It's the effect it's going to have on our code. So let's have a look. We want to add public CB size as a uint. Okay. Okay, I'm going to go with that. Oh, right, we've got this stupid thing we've got to do, haven't we? All right. There we go. So we've now got CB size, style, long pointer for the function window procedure. I think that's going to change, but we'll see. We'll see how that goes. Okay, we're here. Then we've got CB CLS extra. Yeah. CB Windows extra. Yeah. H instance. Handle to the instance, handle to the icon, handle to the cursor. The handle to the brush for the background color. The long pointer to our menu. And a long pointer to our class name. Oh, this isn't as bad as I thought then. Not as bad as I thought. Good. Public H icon SM. Small. Okay. So it's H icon SM. And that's a H icon. There we go. So that's updated. Which means we now need to change over. I think our WinProc's going to be okay. I'm a bit dubious about this. We didn't change anything, so we should be okay. So yeah, this is now an error. Okay. Let's use the right stuff, shall we? All right, that's looking okay. Unsafe definition proc. Yeah, okay. The right register class is now wrong, so that's now got to be an EX. Alright, I think we're okay there. This has to be an EX. And this isn't a function, this is register class. I want capital E, small x. That's an EX. Win class EX returns an atom. It's a constant unnamed parameter. Constant, yeah, unnamed parameter, that's fine. Lovely, thank God for that. That seems to work. Make sure they didn't move it. They didn't. Good. So this gives us access to Unicode instead of UTF-8, ANSI. So UTF-16, I guess, Unicode? I'm not sure. I haven't looked it up, and I don't really care right now. Okay, we're all right there. That's going to cause errors, all these knock-on errors. So we've now got an EX here. That's not going to change anything else there. Are we happy? According to this lot, yeah. What about this lot? Is it just going to be okay with what I've done here? I have asked for defaults. Huh. But didn't it need a size? CB size. We have to provide that. Be sure to set this member before calling that. I think that's part of the required information. How do we get it? It's a U32. And right. It's the size of itself. We can't self-reference this. We actually, I believe we have to change it over. Oh, wait a minute. Hold the phone. Ah. It's self-referencing, and this is, I've got a problem with that. Are we allowed to set it here? So what you would have is WC dot CB size. Wait, but I want to do it before we register the window class. That would equal something or other. WC dot size. Something or other. How do we find the size of a structure? size of a structure. Struct. Oh, it's come up with something. I might have asked the right question. Mem size of my struct. Let's have a look at that. It's in bytes. Let's have a look at that line. Let's see what it's telling us. My struct is going to be WC. Okay. I'll do that. Attempt to use a non-constant value in a constant. I get you. Oh. I see. It can calculate it pre-calculate. Ah. So that doesn't go there. Try and avoid mutating that thing if we can. Okay, it's a U size. That's okay. So how are we going to make this? WND class size. Okay. So CB size, can now equal that? Ooh, that's better than what I was thinking. That's WND class size as U32. There we go, we've got it. I think we've got it. But it does say it's the required information, really. This member can be any combination, yeah, okay. CSH redraw, CSV redraw. Horizontal and vertical redraws. I wonder if that means these bars. Does it tell us anything about these styles in it? Oh, I'd want to complete more of this Win class, but we need to make sure it's working first, don't we? That's a good idea. Is there anything that it should affect? Don't think so. Register window class. We're just doing an unsafe register of the XCW, yeah, with the window class, yeah, that's fine. Okay. There's no error handling there. Dangerous, but fun. I like living dangerously, especially with an API like this. Okay. It worked. All right. So I've changed that over to EXW and everything seems okay. All right, I'll remove it. I'll remove it. Because I've got no error checking, I'm a bit dubious about just doing things like that. So register class is updated. So that's update to register class done. We're going to keep it. To our libs. That's a Win32 lib. Register class. Okay, we'll take it. Looking good. So far, we haven't managed to crash everything. We're down to 9. Wow. So that's handle error, check return values, return non-zero, check docs on return values, handle error, error check, error check. We've got this big to do here. That's error checking, isn't it? Error check. All right. Oh. So after showing the window, we're not updating the window. That will call the win class behavior and do a redraw on the window so you get your background filled in. Update window. Okay. Is that something we have? No. Interesting. So it doesn't seem to be in here. And it wasn't in the... I got this off the internet, don't worry. Google. Just doing Google searches randomly for information on the Windows 32 API. And one of the devs who wrote this stuff suggests updating the window after the show window function. And I thought, well, that's worth looking into. But as we can see, There's an update layered window. Updates the position, size, shape, content and translucency of a layered window. Seems a little complex, doesn't it? All of this stuff needs to be put through. Doesn't refer us, let's get the, that's the device context. We know that now. Ah, create compatible DC. Okay. Interesting to know. Blend functions, okay. It's not referring us through to update window. This is in user 32 DLL as well. For more information, see layered windows. Ah. To update part of a window, use traditional WM paint. We know how out of date all of this stuff is. Ah. Alright, let's try update window. On window update. Okay. It's in Windows. Ah, it's here. Update window function. It does exist. And it is straightforward. And it is in user 32 library. Oh. The update window function updates the client area of the specified window by sending a WM paint message to the window. We are intercepting WM paint and using it. If the Windows update region is not empty, the function sends a WM paint directly to the window procedure. Alright, okay. Of the specified window, bypassing the application queue. If the update region is empty, no message is sent. I see, so it's an optional message. If this function succeeds, the return value is non-zero. If the function fails, the return value is 0. I'm not bothered about it failing if it's optional. Is it something we should use? I believe so. Huh. Okay. Where do we want to put it? After show window here for now. So it would be a public function. You can see what we're doing now is that we're trying to fill in some of the gaps that have been left. Update window comes up. Wow. Alright. And it's just a hwind handle to the window. Yep. Which is a hwind. That's all it's really after. It's an input, so that's okay. And it returns a bool. And we just need whatever we call the window, isn't it? H-wind. Yeah. Okay, I bet it's unsafe, isn't it? Yeah, add unsafe block. I think I want it. I'm going to leave it like that for now. Updates client area of specified window. That'll do. Alright, we'll pop you in. I think I'm alright with that. It shouldn't change the functionality. God, that's bright. It doesn't. Okay. Fine. We're okay so far. That was a to-do, wasn't it? Yeah. We're down to 8. Error check, error check, error check, handle error, check docs on return for those functions. Okay. Translate returns, oh, get out of the way. Returns non-zero for keyboard messages on translate message. Does it now? Oh, of course it will, yeah, because doesn't it recycle the messages? I believe it does. I don't know if that's going to be useful or not. Begin paint, end paint and fill rectangle all have return values. We've got HDC, a bool and a cint. Oh, lovely. Alright. Error checking. Do we really want to be diving into error checking today? Not particularly. I think we've done okay so far. Our refactoring has, I believe, been successful. We are now left with error checking on to-dos. So we are now up to a refactored window. with direct access straight through to creating a Win32 window. We're able to poll the events properly, and we're able to exit the loop in a way I don't like, but we're exiting the loop properly. I'm not sure whether I want to keep this or not. Alright, let's think about it. Alright, I'm just going to put the kettle on. I would say that that was successful. Refactoring isn't usually that difficult, especially on small code base. If you're on a larger code base, you've got problems, big problems, because errors can proliferate throughout your code base quite easily. I prefer to do smaller refactors, and usually as early as possible, so that the proliferation of errors is kept to a minimum. But your code base usually grows and it gets worse. Usually. It's just one of those things. And it's got to be done. You've got to look at your code and say, hold on a minute, I've written all of this stuff, is it really necessary? Is this in... Does this make sense? You've got to take a step back and say, yeah, I've got this prototype code, but is it any good? Does it make sense? Am I going in the right direction? And I think we're now in a position where we can properly program the Windows API. But we need error handling. So I think we might set that up today over a cup of coffee. I've got a horrible feeling there's a can of worms coming up. But you never know. We'll have to create some errors, of course, to test it. That's not usually too difficult for me. I'm sure we can do that. But I'm happy about the refactor going a little bit too smoothly for once. That wasn't a struggle. We'll see, we'll see. Right, I'm going to make a coffee and then we're going to think on how we can do error handling, because it's a whole ball game. Okay, nearly ready. I'll be right with you. Alrighty. I forgot my keys now. There we go. Okay, let's get to a clean state. Yeah. I'm gonna put that to bed. We're going to go into a clean state for further development. So that is first refactor. First refactor complete. I'm just going to leave that. There'll be more. We'll get rid of it. Now, we're going to add window style error handling. Yeah, why do I say it like that? Yeah, Windows style error handling. Let's open a can of worms. We're in a development situation here. We've got semi-decent code that's working, still average. It's slightly above prototype now, but it still is a prototype. We have cleaned it up a little. We've got less to mess around with, which is good. But now we need to extend this into error handling. I'm just thinking, is error handling going to be something I want to do here or in a separate project? Are we going too far? So there's your first choice. Dev project. It's an interesting thought. Because we've only accessed the OS events. We haven't done anything about them, as you can tell. There's a little bit of a gap here in our poll events. And diving into error handling within this project might be too much. If we're going to develop events here, I mean, events, again, is that a separate development project? Probably. Error handling, I think, is a separate development project, but I think we might be able to get rid of that idea by using a minimal error handling routine. What do I mean by that? By making it as simple as possible. I want to crash the program on error. I want to stop the program doing things. I'm not looking to proliferate it back up the call stack like everybody does and handle it and let the user handle the error. All I want to do is to crash out of the functionality and just say, hey, stop, we've got an error, fix it. So this is development error handling rather than, hey, user, you've got an error with your code. Something's not right. So I'm guessing we're doing a different style of error handling here. The other thing is, if we are going to do that, we do have access to the terminal. What do you want to call this thing? To the command line. The user won't have access to the command line because they'll be using it, or they might have actually. That's true, they might have. But a user of an application won't have. The developer of the application will have. We can cover both. We can do both. So the user of an application really wants, if we're going to crash out of the program, we're going to have to notify the user that we're going to do that. And then do it, obviously. But we're going to have to tell them why. We can't just crash the program and they're just left with nothing. That really wouldn't go down too well, would it? Bad user experience. And I think if you're developing the app, it would be nice if you didn't get just a command line bit of text. We got a window opening saying, hey, look, something's not right here. So, where's the problem with this? Actually, there isn't. Now I've just said that. There isn't a problem with that. If we do both, we cover our bases. There isn't a problem. See, the problem could arise that somebody tries to use this library and they don't have access to the Windows API. In that case, trying to just send out messages using a message box won't work because the Windows API provides a message box. So if we cover our bases by using the command line as well, what if that crashes? I don't know. At least we're going to try and get a message out to whoever's developing using this library, and that developer's probably going to be me. Unless you lot want to have a go at this stuff. I mean, it's not harmful. It's nice and straightforward stuff. As long as you don't start running the Windows without a delta time, you'll be fine. Otherwise you are going to cook your graphics card, which is why I'm not leaving the window open very long. We haven't done that test, have we? I think we're safe on what we're doing because we're not doing any work. We're not drawing to the window, are we? I think we're safe. Oh no. We are causing a 10 degrees C increase in GPU temperature. Oh, that's interesting. I wonder if that's just coming from Visual Studio Code at times. Hard to tell with Windows and how it operates. But otherwise, everything is in the green. That's fine. How do we want to do this? Alright, we will need to be doing probably from scratch something along the lines of all of these bits and pieces. What we don't want to see happen is getting to this line here. If we get to this line of code and we don't have a window, something bad happens. Something very bad happens. Because we create the Win32 event. And the Win32 event holds a window open true. So if we get to that line and call this new event, this new function, we're going to tell the user that the window is open. So we have made a guarantee to the user that the window is now open and ready for use. Huh. So this line guarantees that the window is open. This function call guarantees that the window is open. That's what we're saying by writing that one line of code. And we've done a window class and a create window in front of it. So the first one we need to look at is window class. There's already a to-do here. Error check for null. So get module handle W. Should that be EXW? Oh. You see how this has got me thinking? Get module handle W. Where is that coming from? Well, it's not user32. It's coming from the kernel. Okay. It's wide. Does it need to be extended? I don't think it does. It's coming from the kernel. That's awkward. Because it isn't going to be in our list, is it? It isn't going to be in here. This is all user32 stuff, I think. It might be. Get module. Nope. It's not in here. libloader API.h. And there is an EX function. Functions. Yes, folks, we have to look. Yep, get module handle EXW, it exists. I could cry. I really could. Let's have a look at the W. To avoid the race conditions described in the remarks section, use the EX function. Module must have been loaded by the calling process. I got a feeling we're supposed to be using this one. Oh, we've got flags and stuff in here. Parameter can be 0 or 1 or more for the following values. If the module's reference count is incremented, the caller must use free library function to decrement the reference count when the module handle is no longer needed. Oh my god. So we have to unload the handle instance once we've used it. Okay, we've got LP module name, and then we've got the H module. The LP module name we're using. We could pop that in. This option is equivalent to the behavior of get module handle, yeah. Do not pass the retrieve module handle to the free library function. Doing so can cause a DLL to be unmapped prematurely. Oh, great stuff. We love you too. Okay, so we can get around it using that flag. A handle to the specified module. If the function fails, this parameter is null. So they do have a null return. Does not retrieve handles for modules that were loaded using the load library as data file flag. Okay. We're not doing that, I don't think. It's got another error. That's an out. What do we supply? A handle to the specified module. We're not using modules. I don't think this is the right function. I think we've got the right function. It's not deprecated, is it? And we're not using multi-threading, so race conditions, okay. I've got a feeling I'm going to leave this one alone. Creating the calling per, yeah. What's the return values? If the function succeeds, return value is a handle to specified module. If the function fails, it's a null. Excellent. So we do check for null. That's good news. We can check it here. But is this the place we want to do our error handling? No, I don't think so. Yes, it is. It's a variable. Ah. Alright. Let's experiment with error handling. Let's experiment. I want to be able to see everything. What I'm thinking is just doing a simple, straightforward panic, aren't I? So we're looking at something like this. Yeah, I've already been looking into error handling, I know. How do we get a null value? We get a null value from part of our system, don't we? And we haven't used it here. Okay. Did we use it in events? Doesn't look like it. Yes, we did. I thought we had. I don't want the mute. We're not muting. What's wrong with you? Found a raw pointer constant. Okay. Maybe we can use that. C void. Alright, let's try that then. Oh god. That's giving me this standard OS raw. I don't think we can use handle instance, can we? In here. Which gives us handle. Yeah, of course it does. How can we detect a null? Star mute C void. Detecting null. Problem here is that we don't have null. Go to C void, yeah. C void isn't a value. It's a type. And it's telling us here. Yep, okay. It is going to go for that. Alright, I'm gonna go with that then. A null mute, yeah, that's mute. Yeah, that's fine. It can convert, so it doesn't sound too bad. Ah, we've got get last error. What's get last error when it's at home? Well, that's going to be part of the library, isn't it? Yeah, it is. Alright, so we need a library parameter here. Get last active pop-up. We don't seem to have a get last error. Okay, get last error. Retrieve is calling thread's last error code value. The last error code is maintained on a per thread basis. Okay. Post equals last error D word. What? It's a D word. Okay. And it comes under the kernel. So it's a kernel call. Alright. Public function. Get last error. And that returns a D word. Basically. So we've now got a last error as a U32. And we're giving an error code with a last error. Okay. We're panicking, crashing the thing. And we now need to be able to make sure that H instance is a null pointer for this to crash. Alright. So that's our code for error handling. What do we think? What do we think? Is that any good? That code? Unused import. OS raw C void. Okay. I see. It's why you check Clippy. Comparing with null is better expressed by the isNull method. I didn't know there was an isNull method, but we now do. God, I like this language. So this, it is what it's pointing to, isn't it? 51. Ah, of course I've got no lines on here. If handle instance equals that, just do isNull. Okay. You mean something like that? Yeah, okay. Thank you, Clippy. There we go. It says that our code seems sensible. Alright. Application, it still works. Our code is okay. But now we need to check it. Is that going to get us one of these? I don't think it is. We just want to check to make sure that what we're doing isn't completely stupid. So all we need to do is put in let handle instance equal no. And now it doesn't like it. Cannot find value handle instance in this scope. Okay. Type annotations needed for star const. Don't want to make it a star const. It has to be mutable. We want H instance to be a H instance, don't we? Okay. Expected that. Okay. That's the type. Let's see what it wants to give us. If you meant to create a null pointer, use that. Okay. It's asking us to do that again, is it? Okay. Right, so we've got a null pointer. We're going to check if it's null, and if it is, we should crash. Yeah? We agree? Make sure I haven't done something totally stupid. Warning, function get module handle is never used. I bet it isn't. Okay. There we go. So, thread main panicked at source window rs 54 gives us a line number, could not register the window class, error code 0 or null. Run with backtrace if you want a backtrace. So that error will come through and it will stop us getting to our guaranteed line. Okay. So that was a good test. That's the kind of error handling we're looking at. But how useful is this code in this file? Well, let's be honest, it isn't, is it? What we're going to be basically doing is splattering our code with panics. That's the reality of it. Don't we think that that's just going to get in the way? I mean, this code is nice and functional. That's going to get in the way, isn't it? We're just going to have that repeated over and over and... Hold on a minute. Repeat. Did I just say repeated? Yes, I did. That's a function. Are we just going to be dealing with windows? No, we're dealing with events as well. Let's think forwards a bit. We're possibly going to be expanding this API not just to include windows. We're going to probably expand it to include events, keyboard input, mouse input, any number of things. We need a new file, don't we? What are we going to call it? Log error? Error log? Log error. Yeah, I think log error sounds okay. Because then we can develop that into something that actually saves something out to a file if need be on file IO. I'm going to put, again, don't know. To be determined. Let's pop it in. So under modules, we can now have a log error. Yeah. We'll pop it in. We'll pop it in. Module, log error. Alright. So we've now got a module where we can log errors. Huh. We're looking... We can't use the word log, by the way, by itself. Because that's a mathematical function. It's in the thread. This is getting from the thread, isn't it? So it's that bit. We'll cut that out for a second and we'll just pop it in here. That's what we're thinking. Okay. Alright, let's put this into a function then. Probably a public function. I'm not sure right now what we're going to be doing with this. We might be doing a full error logging functionality. We'll just call it log error because we're not being very original. It's going to take in I can see a problem with this already. I don't know. It's going to return nothing. It's a panic. Okay, we'll note that as a panic. We'll fix that. We'll import the crate. Okay. Yeah, that's fine. Right, so we've got a function now that does that logging for us. Not a very good function, I agree. So we would just put in log error panic and see what it does. This is going to give us the wrong result, isn't it? At least we've got a way of testing it. Okay, yep, that's correct. Do, 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 do. There we go. So the error is now coming from log error.rs 5 of 5. Can you see the problem with logging errors? It's now telling us that our error happens on that panic. And it doesn't. Our error happens on that call. So you would need a stack trace to find your error. Can we do that for the user automatically? No idea. So you can see that error logging isn't straightforward already. And this is why I said we're opening a can of worms. But now we can really just put that into one line, can't we? Let's be honest. Oh no, it puts it into 2 lines. Of course it does. 3 lines, never mind. That's how it wants us to write it. That's fine. So now we need to pass. So we might be getting rid of that to do, but what we're now creating is another to do. Report the correct location of the error. As this will give the wrong location. Yeah, there's that. It's doing what we want, but it's not doing it correctly. If we can get this right, we get a system whereby we can just type in one function name for any of the errors that we come across, and it'll just log the error and give us the right result. So logging errors, can we pass through a line number? Will be in runtime. There won't be a line number, will there? Unless it's debug. We'd have to run with stack trace. I don't want to be messing around with environment variables. Can we automatically print out a stack trace from within our code? Huh. It would be helpful, wouldn't it, on this one? Or because we can't get a line number, we won't have one. We have line numbers at compile time. How is it getting the line number then? It must be storing them somehow. Interesting. Get the line number of the code. I don't know. Oh, whoa. Wait, we might have asked it something correct. What's going on? Line pling. What does that resolve to? A U32. Interesting. Let's see if it works. I don't know if it will or not. Is a U32, please. Will that work? It says it will. So that gives us an error code. That'll give us a line number. We'll need a file. Let's just see if we can get a line number to start off with before we start messing around that. Da, 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 da. Error code. We'll need line number here. Do we need a comma? Probably. Okay. Still got an error going, yeah. On line 57, which obviously disagrees with this. So how does it get this? Dynamically. No, I don't want dynamic. Oh, wait a minute, do we? Ba 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 ba. Yeah. Blah 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 blah. Yeah. You're talking about source files, aren't you? This is going to be a problem. Yeah. I put up the code. Okay. File pling. Well, that makes sense. File pling. I wonder if that will do anything. We can try, can't we? So, let's try this out again. What do we get for a file pling? We get an and string. Wonder what that kind of result will give us. Okay. It's interesting. I have to admit, and string. Okay. And str. Okay. Get rid of that line. Now we can put file number, file name, in file, error, process didn't exit successfully. Yeah. Alright, let me just clear the screen a minute, because that's a lot of garbage. That's the message we're printing out. It works. Maybe we should structure it the same way as they have done. So file, line, yeah, we need to structure this better. Definitely. How can we do it? So that's doing file line. Okay. Let's structure it in the same way that Rust has structured things. So I think that might help identify things anyway. Okay, so we'll do file name and then line number. File name and line number. File, line, error code in file, online. I'm also going to try out something silly here. Oh, it just puts it on. Yeah, okay, that's fine. This needs to be changed around, doesn't it? All right. Do we get something that's clearer instead of just a jumbled mess trying to hunt through it? That's the question. Could not register the window class. Error code 0. Where did this come from? Oh, right. I put that in, have I? Error code 0. In file source blah 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 blah. And it gives us a clickety clickety thing. That's good. Log error, yeah. And then it gives us the actual error. We've got 2 lines here. We can reduce that. I think we only need 1 line. Yeah. Alright, so this needs to be a string. Really? I'm going to put a space in as well. Just see how that looks. here we will have a message. I'll put a string in here. And here we can just type in something like that. Yeah. Blah, blah, blah. And we need last error now becomes message. Does this now make sense? Message, file name, line number. Okay. I think we've got something. I think we're onto something. It's silent. Could turn your log error function into a declarative macro. That way you get the correct location. I've got the correct location. Yeah. I'm not really particularly a big fan of using macros, even though we are using macros here and here. They tend to obscure code. I have created macro. I've created one macro in this, and I'm not a big fan of even that, but it was more out of necessity rather than anything else, because we don't have a C hash derive, and we needed a default on our C structures, so I did make a macro for that. Well, I looked up a macro for that. I didn't make it. Alright, I've got some red bars going on down here. Okay, that's fine. What's going on up here? Just a red bar. That's fine. That's my first test of error handling. Construct the window, yeah. Window class. So this is our first test piece. It's not overly complex, but we've still got a problem that a user of the final application won't have access to this message. They won't have a command line. So now we're looking to expand this, aren't we? One of the things I look for when I'm prototyping is the simplest solution you can come up with. And that is the simplest solution I can come up with. So I think we'll stay with this as a prototype. Later on, turning things into macros and stuff, if you think it's necessary. Do you think it's going to speed up the program? I hesitate to say yes, it will. But now we come to doing the real error handling, because we don't just want to panic here. We want to be able to inform people who don't have this message that there's something going on. So now we do have a to-do. It's one of these rather interesting things about dealing with the Windows 32 area, is applications will not necessarily have the command line. So to do report error in a message window. Yeah, okay. The user may not have a command line available. What happens to our message if there's no command line available? I think it goes through to a null terminator and just gets gobbled up by the operating system. It does in Linux anyway. On Windows, well, anything can happen, I guess. That's the usual method that an operating system would use. It would just send it off to a null termination bin and bin it. If you pipe to a null, it usually bins things. That's the theory, so hopefully that will just disappear. I can't guarantee that though. That's the theory. In practice, anything can happen at this point. We'd need to use message boxes. How easy are they to use? It should be straightforward. The Windows 32 API gives you, this is what I don't understand, message boxes. Mini windows with a button. It can't create you a window with all the bells and whistles, but it can give you a message box without a problem. That makes me suspicious. So they've actually tried to make that part of the API really easy to use, and I think this is the reason why. So, error handling, how close are we? Not really that close. But it's there. We're down to 7 to-dos. And log error.rs hasn't come up. Can we refresh this? 8 results, that's better, yeah. Okay, I'm a little bit more happy with that. So we've also got test code in here now, haven't we? Yeah, we have. Debug. Please remove this code. Okay. Yep, always mark your debug code. Don't just leave it lying around. Okay. So we've got a bit of debug code that we can now use for this error handling stuff. And we've got a successful message going to the console. All right. Okay, how can we put this in? First, so it's a first. First code for logging errors to console only. Alright, I'm going to put that in because it matters to the way my thoughts are going. Yeah, I'll go with that. I think we're okay. And I didn't check it ran. Any cleanup required? We're going to find out now. Nope. And everything should work perfectly well, except for our mouse pointer. Alright. Yeah, everything's working. That's fine. So we haven't messed up our code. Our handler for logging errors has come to life. It's probably not put correctly in there, but hey ho. I'm going to go with it. I'm going to go with that code. And see where that takes us. I don't need to make it public. Libraries are okay. Window and log errors, yeah, we're okay now. And that hasn't affected anything here, but now we've got the ability to log errors. It means that we'll be able to go through our code and log console errors. But that's not quite what we're after. I think we need to expand on that a little bit more and then do full error handling. Yeah. So that's where we're up to. We've done a refactor and improved our code, and we've started to look at error handling. I think we need to do full error handling, including the window message box. Yeah. So that's going to be the next stage of this project, is going to be doing that. I'm happy that we got that refactor done and we got our code slightly cleaned up. We have improved our code, yes. Okay. What do you think? I think we did well. I think we did well for a nice, easy, relaxed Sunday morning. Oh, it's now afternoon. Wow, time flies. So, I'm going to get off and get some food. You people, thank you very much for popping by. We are going to continue this and complete error coding. Or error logging, should I say. I need to think on how far I want to take that. Maybe just keep it simple for now? Probably. But in the meantime, if you have any ideas, I do put this up on YouTube. I'll put it in the comments on YouTube or something. If there's anything I've missed, well, there's tons I've missed. I mean, I've put notes in for that. We'll see. We'll see about those notes. I want to have a look at that mouse pointer as well. Okay. Take care and have fun.